Welcome to the deep dive. We're here, as always, to cut through the noise on complex topics using solid source materials.
And today, we're tackling one that's definitely up there in terms of being everywhere, but also kind of nebulous.
Exactly. We're talking about the cloud. Everyone uses it, businesses depend on it, but ask for a clear definition. Things get fuzzy fast.
They really do. It's become this catch-all term.
So our mission for this deep dive is pretty straightforward. Give you a simple, jargon-light explanation of cloud computing basics. And we're aiming for under 15 minutes.
Yeah, the goal is you walk away actually understanding what it is, how it works, and, why it's taken over.
Okay, let's start right at the core. What is cloud computing, fundamentally?
Right. So at its heart, cloud computing is really just the on-demand delivery of IT resources. Think servers, storage, databases, software.
Delivered how?
Over the internet. And the really key part is the pricing model. It's pay as you go.
Okay, so it's not just remote servers, it's this access model.
Exactly. The cloud itself is just a metaphor, really, for this huge network of remote data centers running everything.
I really like the analogy from our source material comparing it to, like, entertainment.
Oh, yeah, the Netflix one.
Yeah. Before the cloud, wanting computing power was like buying DVDs or Blu-rays for every single movie. You had to own the physical thing, store it, maintain it.
Your own servers, your own data center, maybe in a basement or a closet somewhere.
Exactly. Whereas the cloud is much more like Netflix. You're renting access to those computing resources, the power, the storage, the apps, instead of buying and managing all the physical hardware yourself.
That nails it. It shifts IT from being this massive upfront capital expense buying stuff to more of an ongoing operational expense, like paying an electricity bill.
So let's dig into that before a bit. What was the pain point? Why were businesses so ready for something different?
Oh, the pre-cloud world.
Yeah.
Well, for IT departments, it was often pretty brutal. If your company was growing, you had to guess your peak demand maybe years in advance.
And buy servers for that peak?
Precisely.
Mm.
Which meant most of the time, a lot of that expensive hardware was just sitting there, idle, costing money. You had the physical servers setting up data centers, the power, the cooling, the IT staff for maintenance, upgrades. It was a huge capital investment, CapEx, and honestly, often really inefficient.
So now companies like AWS, Microsoft Azure, Google Cloud, the big providers they own and run these massive physical data centers. But how do they actually share that same physical machine among potentially thousands of different customers safely?
Okay, yeah. That's the magic trick, right? The core technology that makes almost all of this possible is virtualization.
Okay, virtualization. It sounds technical. If I'm renting server space and maybe like 10 other companies are on the same physical box, how do I know my stuff is separate and secure?
That's exactly what virtualization does.
Yeah.
Think of a really powerful physical server. Virtualization software acts like a divider, splitting that single piece of hardware into many independent, totally isolated virtual machines or instances.
No, like apartments in a building.
Perfect analogy. Each customer gets their own secure, walled-off apartment, their virtual machine on that shared hardware. This whole concept is called multi-tenancy.
Oh, wait, multi-tenancy? So
Yeah.
because that software creates these like virtual walls, my company's data can't accidentally spill over into someone else's virtual machine, even if we're technically running on the same physical server.
Correct. It's fundamental. That isolation is key. It lets the providers use their hardware super efficiently, driving down costs while giving you secure access from basically anywhere with an internet connection.
Okay, that makes sense. The virtualization is the how. So now that we know the resource can be shared securely, how do you actually buy it? Let's talk about the main ways people consume cloud services, the as-a-service stack, right?
Exactly. And the key difference between these models is how much control you, the customer, actually keep versus how much the provider manages for you. It's a spectrum.
All right, where do we start?
We usually start at the top, with the simplest option where the provider manages pretty much everything. That's SaaS.
SaaS, software as a service. Okay, this one feels familiar. I think most people use SaaS every day without maybe even calling it that.
Absolutely. With SaaS, the provider hosts and manages the entire thing. The application itself, the underlying infrastructure, the operating system, all of it. You, the user, just access it, usually through a web browser or a dedicated app.
So examples would be Gmail, Salesforce, Dropbox, Office 365.
Yep, all classic SaaS, even Zoom, or our earlier example, Netflix. You just use the software. You don't think about the servers it's running on or updates or maintenance.
Maximum simplicity, minimum control for the user.
That's the trade-off. If your SaaS provider has an outage, Like, say, if Gmail goes down?
You're stuck. There's nothing you can personally do to fix it.
Exactly. You've traded control for convenience. Okay, moving down the stack a level, we get more control. This is PaaS.
PaaS, platform as a service. If SaaS is the finished software, what's the platform here?
So, with PaaS, the provider gives developers a ready-made environment, a platform to build, deploy, and manage their own applications. The provider handles the underlying infrastructure, the servers, the operating systems, the scaling, the networking.
Ah, okay. So the developers don't have to worry about managing servers or patching operating systems?
Right. They can just focus purely on writing their application code and getting it running. They manage their app and their data.
Got it. So less infrastructure headache, but you still build and run your own thing.
Yeah.
Examples would be things like Heroku or Google App Engine. AWS has Elastic Beanstalk.
Those are perfect examples. It's that middle ground. Now, for the most control, we go down to the base layer, IaaS.
IaaS, infrastructure as a service.
Right.
Infrastructure. So this is like the raw building blocks.
Exactly. With IaaS, the provider rents out the fundamental IT components, virtual machines, raw storage like hard drive space, networking capabilities. They manage the physical data center and the hardware,
The actual map.
right? The bare metal and the virtualization layer on top of it. But you, the customer, manage almost everything else. The operating system, any middleware, your applications, all your data.
So this gives you the most flexibility, like having your own data center, but without buying the hardware. This is where you'd see things like Amazon EC2 instances or Azure virtual machines.
Precisely. It requires the most IT expertise on the customer side, but offers maximum control over your environment. So that stack SaaS, PostGIS, IaaS, that's basically your menu, depending on how much you want to manage yourself versus letting the provider handle.
That framework makes a lot of sense. Okay, so we know what it is and the ways to buy it. Let's talk about the why. Why the explosive growth? We mentioned cost savings that shift from CapEx to OpEx, but what else?
I'd say arguably the biggest driver after cost is scalability.
Right, explain that.
Think back to those pre-cloud days. If your website or app suddenly got featured somewhere and traffic exploded
The
overnight.
servers would probably melt, crash and burn.
Exactly. And getting new hardware could take weeks or months. Your business opportunity might just evaporate. With a cloud, you can scale your resources, add more servers, more storage almost instantly. Click a button.
And just as importantly, you can scale down too, right? So you're not paying for capacity you don't need during quiet periods.
Precisely. You match resources to actual demand, up or down. This avoids waste and handles unexpected peaks smoothly.
And that ability to get resources so quickly, that ties into agility, doesn't it? Businesses can try new ideas, launch apps, iterate much faster.
In minutes, literally, instead of months waiting for hardware. It dramatically speeds up innovation. And then there's the whole aspect of reliability and security.
That seems huge. Can smaller companies really rely on these providers to be more reliable than they could be themselves?
Generally, yes.
Yeah.
The major cloud providers invest billions in building redundant systems, backup power, sophisticated disaster recovery plans. They often mirror your data across multiple physical locations, sometimes even different geographic regions.
So if one data center has an issue,
Your services can often fail over to another one automatically.
hmm,
Plus, their security measures, both physical security of the data centers and cybersecurity expertise, are typically far beyond what an individual organization, especially a smaller one, could afford.
okay, those benefits are definitely compelling. Cost, scalability, speed, reliability. But it can't all be perfect. You mentioned losing control with SaaS. What are the main drawbacks or sort of hidden challenges people need to watch out for?
Yeah, there are definitely trade-offs. 4 big ones come to mind. First, downtime. As reliable as they are, providers do have outages, and if your provider goes down, your systems go down. You're completely dependent.
Okay, that's a risk. What else?
Second, data privacy and security concerns. While providers have strong security, you are still putting your sensitive data on someone else's servers. For industries with strict regulations like finance or healthcare, this requires very careful consideration and configuration.
Makes sense. You're trusting them with your crown jewels, essentially.
Exactly. Third, and this is a big one businesses often hit later, vendor lock-in.
Explain that. Sounds sticky.
It can be very sticky. Once you build your systems using a specific provider's proprietary tools and services, maybe their specialized databases or AI platforms, it can become incredibly difficult, time-consuming, and expensive to switch to a different cloud provider later on. You're sort of locked into their ecosystem.
Right. They make it easy to get in, but maybe not so easy to leave.
That's the concern. And finally, back to cost. That wonderful pay-as-you-go model. It can actually become a disadvantage if you're not careful.
How so?
If you don't actively monitor and manage your cloud usage, maybe you leave test servers running or over-provision resources, those costs can spiral surprisingly quickly. It's like leaving the meter running. Unmanaged cloud spend is a real issue for many organizations.
Yeah, I can see how that utility bill could get scary if no one's watching it closely. Okay, so we have the models, the pros, the cons. Let's quickly touch on how these services are actually structured, the deployment models.
Right. This is about where the infrastructure lives and who uses it.
The most common is probably the public cloud, right?
Yes, public cloud is kind of the default. This is where services run on hardware owned by the provider, and that hardware is shared by multiple customers. Remember, multi-tenancy. It's typically the cheapest, most flexible, and easiest to scale. AWS, Azure, Google Cloud, these are primarily public cloud providers.
But some organizations can't use shared infrastructure, maybe for security or compliance reasons.
Correct. That's where the private cloud comes in. The infrastructure is dedicated solely to one organization. It might be located in their own data center or hosted by a third party, but it's not shared. Offers more control, potentially better security, but it's more expensive and less flexible than public cloud.
Like a big bank might use.
Exactly. Now, increasingly common, especially for larger companies, is the hybrid cloud.
Hybrid, so remixing them.
Yep. It strategically combines public and private clouds. Maybe you keep sensitive data on your private cloud, but use the public cloud for less critical applications or for bursting capacity during peak times. Data and apps can move between the two. It aims for the best of both worlds, security and scalability.
And what about dealing with that vendor lock-in problem we mentioned?
That's where multi-cloud strategies are becoming really popular.
Multi-cloud, so that means using more than one cloud.
More than one public cloud provider, typically. So maybe using some services from AWS, some from Azure, maybe some from Google Cloud, all at the same time. The idea is to avoid putting all your eggs in one basket, maybe leverage specific strengths of each provider, or negotiate better pricing.
Got it. Spreading the risk. Okay, this might still feel a bit abstract for some listeners. Let's bring it home with some real-world examples. Where do we see cloud computing making a tangible difference?
Oh, it's literally everywhere. Think about massive scale streaming. Netflix runs almost entirely on AWS, delivering billions of hours of video globally. That requires a kind of instant scalability only the cloud provides.
Wow. Okay, Netflix. What else?
Companies like Airbnb or Uber, their entire global operations, managing bookings, drivers, locations, fluctuating demand across continents, that's all orchestrated using cloud services. They couldn't exist at that scale without it.
And what about cutting-edge stuff, like AI?
Absolutely crucial. Training and running large AI models, like the ones behind ChatGPT or other generative AI. That takes enormous amounts of computing power. That kind of power is really only accessible and affordable on demand via cloud infrastructure.
So it's enabling things that just weren't feasible before. And it's not slowing down, is it? What are some emerging trends pushing the boundaries even further?
Now, it's constantly evolving. One big trend is serverless computing.
Serverless? But aren't there still servers somewhere?
Well, yes, physically there are, but you don't manage them at all. With serverless, like AWS Lambda or Azure Functions, your code just runs in response to events. You upload your function, and the cloud provider handles everything about executing it when needed. You only pay for the exact compute time used, down to the millisecond. No server provisioning, no patching.
Okay, taking abstraction even further, what else?
Edge computing. This is about moving compute resources closer to where the data is generated or where users are. Instead of sending everything back to a central cloud data center, you process data at the edge of the network.
Why do that?
Speed reduces latency. Think about self-driving cars needing instant decisions, or IoT devices in a factory. Sending data all the way to the cloud and back is too slow. Edge computing provides faster responses, and way out on the horizon, though it's still very early days, is the quantum cloud.
Renting time on quantum computers via the cloud?
Exactly. For incredibly complex problems in things like materials science or drug discovery that classical computers struggle with. It's niche now, but it follows that same cloud service model.
Fascinating. Okay, let's try and wrap this up. If you're listening and trying to boil this down, what's the main takeaway?
I think the absolute core idea is that cloud computing fundamentally shifted IT. It changed it from being primarily a capital expense, buying big, expensive hardware up front, into an operational expense, basically. Renting computing power like a utility, paying as you go.
And that shift enables all the things we talked about. The speed, the scalability, the agility for businesses to innovate faster.
Right. And understanding those three main service models, IaaS, PaaS, and SaaS, helps you understand the menu of options. It's all about how much control you need versus how much you want the provider to manage for you.
From raw infrastructure to a ready-to-use application.
Exactly.
So maybe a final thought to leave our listeners with, something to chew on.
Well, thinking about the future,
Hmm.
we see this huge reliance on just a handful of massive cloud providers, right? And we talked about vendor lock-in being a real risk. Companies are trying to mitigate that with multi-cloud strategies.
Okay.
So here's the thought. As potentially game-changing technologies like, say, quantum cloud eventually become more mainstream, how will that interact with this landscape?
Hmm.
Will the need for that kind of specialized cutting-edge power force companies back towards deeper integration with single providers who offer it first, potentially worsening lock-in? Or will new models emerge to keep things open? It's sort of a tension between needing ultimate capability and avoiding dependence.
Interesting. The push and pull between relying on these giants for innovation versus the desire for flexibility and avoiding lock-in, definitely something to watch.
For sure, the structure of the internet and computing is still very much evolving.